Hello everyone, we are solving a problem on homogeneous equations. So we recognize this type usually because you should have sine squared of x, cos squared of x, and sine x cos x in it. So at this point, it's really not obvious that it's an homogeneous equation because we only have cos squared. We don't even have any of the other two. So let's see what happens when we try solving this problem. The first thing I notice is that we have here a 2x and here we have an x. So that's a problem. We need to have the same angle. So to get the same angle, we're obviously going to go and use a double angle formula for sine. So if you don't remember what it is by heart, then please go and check on your sheet. I'm going to write it down anyways. So the formula is 2 times sine x cos x. I'm going to put the 2 at the front just because it's going to look nicer. And here it's becoming a sine of x times a cos of x minus 2 times root 3. All right, the rest stayed the same. So now that we're here, we got the sine x cos x showing up, but we still don't have the sine x, the sine square x. Still not very obvious what we have to do with this. First thing I do notice though is that we've got 2's in front of every single term. So let's just divide the whole equation by 2. Here we're going to get 1, and these 2 are gone. So now that we have that, the question is, what do we do? One thing you might notice is that we have cos squared and cos here. You could try and factor out a cos out of this for that reason, but the issue here is the fact that it's going to be equal to 1 and not 0. It looks like a factoring type, but if it's not equal to 0 on this side, then we won't know what to do about it. So this probably won't help. So we're at the point where we need something else, and one of the tricks that we can use here is using the Pythagorean identity, which is sine squared plus cos squared equals to 1 because we have a 1 right here. So here I would put it as sine squared plus cos squared instead of 1. I'm just going to write it here because I want to save some time. So this one here is going to be sine squared of x plus cos squared of x. And now we've got everything we need. If you look here, we've got the sine squared, we've got the cos squared, we've got the sine x cos x. So we've managed to transform the equation into something that we have all the elements required to use the trick, which is dividing by cos squared. So now we just got to simplify it. Let's see. We should probably just bring everything to this side. So let me do that. We're going to get, and I'm probably just at this point going to open my brackets because it's kind of blinding us a little bit. So here we're going to get, I'm sorry, I wrote a line, sine x cos x plus sine x cos x. And then here we're going to get minus square root 3 of cos squared plus cos squared. And then I'm just going to bring the 2 terms that I have here on the same side and therefore get minus sine squared of x minus cos squared of x. And this is all equal to 0. That was a little bit long. Let's see. So now we've got things canceling out. That's the point. So we've got the cos squared here that's gone with this one here. And then one thing you might notice, you might not notice anything by now. Honestly, we should probably just be at the point where we should go ahead and divide everything by cos squared because there's nothing obvious otherwise that should happen. So let's divide everything by cos squared of x and therefore get tangent everywhere. If you recall, that's what happens in this type of problems. And obviously cos squared cannot be equal to 0 because then we would divide by 0 and that's not allowed. So if you recalled in class, what I said is when we have the sine x cos x and divide that by cos squared of x, the only thing that should be left is tangent of x. And please break it down and do it on your own if you don't remember why this happens. Same thing for the next term. So we're going to get another tangent of x. And then for this one here, we're just going to be left with minus square root of 3. This term here is going to become minus tangent squared of x, and that's it. equals to 0. So now this is pretty nice. What I think I'm going to do is, since we have tangent everywhere, and we have a root 3 here, 1, and 1. So we should probably pair them up and see if that works. Hopefully that's going to work. So I'm going to pair the roots together and then the ones together. Sorry, it's a little hard to move the screen. Okay. All right, let's do that. So if we pair these two together, I'm going to factor out root of 3 out of them and get tangent of x minus 1. And then for the second pair, I'm also going to factor out tangent, but I'm going to factor out minus tangent, I think, just because then the signs inside the brackets are going to be the same. I'm going to be left with this. For this term here, it's just going to be tangent of x. And then for the other term here, this should be minus 1 because minus tan of x times minus 1 is plus tangent of x. This is equal to 0. And now, again, factor out the brackets. So tangent minus 1 goes in front, and then root of 3 minus tangent of x is equal to 0. So we didn't even need substitution for this, which is quite nice. We've got two smaller equations to solve. Let's do that. First one is pretty simple, is tangent of x is equal to 1. I've explained this in class before. If you recall, I said tangent is sine of x over cos x, which means really what we get is that sine of x and cos of x have to be the same number because that's the only way we get 1. So if they are the same number, there's 2 points on the circle where this happens, at pi over 4 and 5 pi over 4 right here, these 2 points. Therefore, the only angle that should work is going to be pi over 4. I'm going to put them together because it's a simple one, plus pi m. Because to get from one point to the other point, we just add pi, and then to get to the next one, we add pi again. So this one here is the only angle we need. Second one is tangent of x is equal to square root of 3. You might actually know this one by heart by now, because I think for tangent, it's quite simple. I'm going to do it again just because why not? So if you recall, what I told you is draw a line here, a tangent to the circle, and then go on the number line for y and find the number that I gave you, which is square root of 3, about 1.7 something. It would be up here. And then this point on that line would be this point right here. So our triangle is this triangle. It has root 3 here, 1 here, and therefore the hypotenuse is square root, no, it's not square root of 2, it's square root of 4, which is just equal to 2. Therefore, this is a 60-degree angle, or pi over 3. So our answer for this one, x2, is going to be equal to pi over 3 plus pi times m, because it's a tangent. So this is the second angle that works for this problem. Thank you for listening.